Welcome to Lesson 3, Exploring Apex Solids, where we are going to work on defining and determining the volume of apex solids. Okay, first things first, we have to define what an apex solid is. We're going to use these examples and non-examples here. So when we look at our non-examples, what I'm noticing is that there are two bases, a top and a bottom base, that are both flat. Okay, and I'm noticing too that for the most part, all of the sides, right, go all the way around the base, which seems to be a similarity with our examples. Okay, looking at our examples, each one only has one base and the sides or edges come to a point. Okay, and so that's what our apex solid is. So go ahead and write this with me. An apex solid is a three-dimensional shape that has one base whose sides or edges form a point. Okay, so basically this word apex here means point, like the highest point of something. Okay, and so in class we watched a video or did an activity to help us determine the connection between apex solids and solids that have two bases. And so the big idea is that apex solids have a third of the volume of their matching or parent solid that has two bases. And so we're going to write that down, the big idea. So how do I determine the volume of apex solids? We're going to say I determine the volume of apex solids by dividing the total volume of its matching solid that has two bases by 3. Okay, and so let's go ahead and get you the names for our 3 apex solids that we're going to be working with today so that our formulas make a little bit more sense for you. Okay, up first in green, this is a cone. Okay, now a cone is related to a cylinder, and we know that because the base is a circle. In the middle, we have what's called a triangular pyramid or a tetrahedron. We know that the triangular pyramid is related to a triangular prism because the base is a triangle. And lastly, on the right in orange or yellow, we have a rectangular pyramid. And this shape is related to a rectangular prism, and we know that because the base is a rectangle. Okay, so let's go ahead and write down our formulas. So since the cone is related to a cylinder, volume is 1/3 the volume of a cylinder. So 1/3 times pi times the radius squared times the height. For our triangular pyramid, since it's related to a triangular prism, we know that volume is going to be equal to 1/3 of the prism volume, so 1/2 times base times the height times the length. But this formula gets a little bit messy, so we're going to go ahead and clean that up by multiplying our fractions. So the formula we're going to be using is actually 1/6 times base times height times length. But again, that's just to help us stay organized. And lastly, we have our rectangular pyramid, which is 1/3 of the rectangular prism. So we're going to have 1/3 times the length times the width times the height. Okay, so again, I just want to point out to you the 1/3 in each of our formulas and how it is 1/3 times its parent solid that has two bases. Okay, and with that being said, let's get started. So we're going to be determining the volume of each apex solid. There's 9 in total, 3 on the first page, and we are rounding to the nearest tenth, which is 1 decimal place. To help us determine which formula to use for the apex solid, look at the base. Okay, so for number 1, I'm going to highlight the base. You can also highlight, outline, or color. Since our base is a rectangle, that means that this is a rectangular pyramid. So let's write down that formula. So volume is equal to 1/3 times the length times the width times the height. Okay, so the length here is 13, the width is 6, and the height is 14. You're going to put all of that in your calculator at the same time, and when you do, you learn that volume is 364 cubic centimeters. It's very important that we include our units of measurement all the time. Let's look at number 2. So let's go ahead and color in the shape of our base. The shape of our base is a triangle. So that means this is a triangular pyramid. The formula for that volume is 1/6 times the base times the height times the length. So we are going to have 1/6 times 15 times 15 again, and times 20. Put all of that in your calculator, and you learn that volume is 750 cubic yards. And number 3, go ahead and look at the shape of our base. The shape of our base is a circle, so that means we're working with a cone. And the formula for volume of a cone is 1/3 times pi times the radius squared times the height. So our radius here is 5 and the height is 18. Remember, be very careful not to mix up the radius and the height. They have to go in the correct spots in their formula, because if you swap the 18 and the 5, then the exponent right here of 2 ends up on the wrong term. Okay, for our pyramids, order doesn't matter so much with what number goes where, but for our cones, it very much matters which number is the radius and which one is the height. After putting all of this in a calculator, we'll learn that volume is approximately 471.2 cubic feet. Okay, before we continue on, I want to point out a couple mistakes that we see commonly. First thing, calculators. We have to make sure we're practicing using our calculators. And when we're using the calculators, sometimes we have a tendency to forget our fractions in the calculator or forget pi or the exponent. So just be mindful of that. The other area where people struggle is identifying which formula to use. So again, get in the habit of coloring the bases so that you have a very clear idea of what formula to use based off of what shape the base is. Okay? So for number 4, our base is a rectangle. So that means we're going to calculate volume for a rectangular pyramid. So 1/3 times the length times the width times the height. So the length is 21, the width is 21, and the height is 29. Put that in your calculator, and you learn that volume is 4,263 cubic meters. For number 5, the shape of our base is a triangle. That means that we are going to calculate volume for a triangular pyramid. So our formula is 1/6 times the base times the height times the length. So our base is 12 inches, the height is 3 inches, and the length is 8. Go ahead and multiply those terms together, and you learn that volume is 48 cubic inches. With number 6, it looks like our cone has fallen over, but that's okay. The base is on the side this time, but it's still a cylinder. So we've got a cone. Formula for volume is 1/3 times pi times the radius squared times the height. Okay, the radius is 6 and the height is 17. Okay, be very careful typing this in your calculator. When you do, you'll learn that volume is approximately 640.9 cubic feet. Now, words of wisdom here. The work that I'm showing here on the screen is the expectation for you showing your work, okay? To earn points on notes and assessments and homework, you have to show all of the steps, not only the answer. And we really need to get in the habit of writing down that formula every single time. It's good for you. All right, last three. For number 7, the shape of our base is a rectangle. That means that we have a rectangular pyramid, and the volume formula is 1/3 times the length times the width times the height. So the length here is 32, the width is 17, and the height is 24. Put that in your calculator to simplify, and you learn that volume is 4,352 cubic feet. All right, with number 8, the shape of our base is a triangle. So that means this is a triangular pyramid. The formula for volume is 1/6 times base times height times length. So that means that the base is 13, the height is 8, and the length is 17. Put that in your calculator to simplify, and you learn that volume is approximately 294.7 cubic inches. Last one, number 9. The shape of your apex solid is a circle, so we have a cone. So formula for cone volume is 1/3 times pi times the radius squared times the height. That 1/3 and pi are part of the formula, so we're going to write those down again. Now, when you look at our cone for number 9, I want you to notice how the 6 inches goes all the way across. That means that 6 inches is our diameter. Just a reminder from Unit 6 that the radius is half the diameter. So if the diameter is 6, divide by 2 to get the radius. That means the radius is 3, and our height is 10. So we have 1/3 times pi times 3 squared times 10. Go ahead and simplify that expression in your calculator, and you learn that volume is approximately 94.2 cubic inches. All right. Couldn't finish these notes without a reflection question. How do I determine the difference between the varying types of apex solids? Well, are you ready? Remember, we look at the bases. So let's write it down. I determine the difference by looking at the base of each apex solid. All right, and there you have it.